Hi folks, Matt McSpirit here, Technical Evangelist and member of the Ops team here at Microsoft. Continuing our series as we look at the 10 reasons why you'll love Windows Server 2016. We're back at Building 10 here on Microsoft campus to meet with Taylor Brown, who's going to give you everything you need to know about the new container technology in Windows Server 2016. Let's go meet him. So Taylor, thanks for joining us. Bring us up to speed with what you do at Microsoft.
So I'm a program management lead for Windows containers. So all of our server container technologies fall under my team's charter.
Okay, cool. So containers, a new technology to Windows Server, especially, definitely new to me. When we think about containers in the industry, they've been around in Linux for some time. Bring us up to speed, especially for those who aren't as familiar with containers, just what they are, what they can do, and what they're solving for.
Yeah, definitely. So yeah, containers have been around in Linux in some form or another for nearly 10 years now. They kind of came together as we think of them now in two different technology spectrums coming together. Google did a bunch of work many years ago on what they called C groups, which is a way to kind of aggregate processes together and put some resource controls on them. You can imagine that'd be pretty handy for running cloud-based services. And then IBM kind of spearheaded and kicked off some work for what they call namespaces in Linux, which allow you to kind of isolate what a process can see and whatnot. This is often referred to as like char root and some of those technologies.
Right.
And then a couple of years ago, a company called .cloud at the time, now Docker, made a tool that kind of combined these two together into what we really think of as a container generally today, which is this combination of process isolation and namespace isolation, and really took off in Linux quite heavily. And so as we kind of looked at that and looked at what our customers were thinking about and needing, we brought similar technologies into Windows, and then we've been working within Docker as a public open source project to add Windows support into the Docker engine. So at this point, we now have that support in the Docker engine, so you can create containers, you can start and stop manage containers through the Docker engine with the same tool set as you would with Linux.
Right, so we'll talk a bit more about Docker as we go forward, but before we do, bring people up to speed with just a comparison perhaps with traditional virtual machines today, because I think many people are used to that. You've got a VM, it's hardware isolated, it uses a virtual disk. Many of us are familiar with that, so compare and contrast.
So virtual machines were a technology that I've been a part of at Microsoft now for 13 years. And when I first saw it, it was amazingly compelling. So what it allows us to do is to pretend that we're a full machine. So we can take a single machine, your laptop, a server in the data center, whatever, and emulate a whole set of other machines on it, each one of them with their own operating system running inside, right? And so this gave us really high utilization of hardware. It took the servers that we had that were really overpowered for a lot of what they were doing at the time. You think of your print spoolers and stuff like that, and allows us to share those up and divide them up. That's really formed the foundation of all of our cloud technologies today. Everything we think of in the cloud is by and large run in virtual machines. What containers do as a contrast is they virtualize the operating system layer. So instead of pretending to be a full piece of hardware that you can run any OS on, they just pretend to be kind of a clean copy of that operating system. So we can now take a copy of Windows Server and basically divide that up into smaller isolated chunks. And sometimes I refer to this as kind of just enough virtualization, because really where we're seeing a lot of the innovation occur right now and the rapid innovation isn't at the operating system level. We're still innovating the operating system fast, but it's the applications that are really innovating. We're going from a model of, a few years ago we'd ship a new version of an application once a year maybe. Now we're shipping new versions of applications into the cloud several times a day, in some cases several times an hour.
So containers are giving you increased speed and agility versus virtual machines? I mean, how quick is it to spin up a new container?
We can spin up a new container in about a second.
Compared to a VM that may take a fair few, depending on what's running in there, and you've got storage requirements for a VM as well. What about container storage?
So containers build on this notion of an image. And so you end up shipping just the pieces that have kind of changed around. So if you've got a server with let's say nano server container image on it, and I've got a server with a nano container image on it, and I build a new application based on that, I just ship you the changes that I made to that image. So you don't have to download that whole image on your machine. And so if you think about that, it's scaling out to the cloud. where I'm now pushing that out to maybe 10, maybe 100, maybe 1,000 virtual machines, that delta of just shipping the changes is pretty significant.
So that really gives us a lot of speed, a lot of agility, a lot of flexibility. We're saving on storage.
Yeah.
When it comes to containers, though, it's the isolation level. You mentioned namespace isolation, so each individual app thinks it's got its own environment, or it has essentially.
Yeah.
But what about other runtimes within the Windows Server platform? So tell us a bit more about Hyper-V containers and where they differ.
Yeah, like I was saying earlier, with the Linux model, there's still a shared kernel, and really Windows Server containers follow that same model where we've got a shared kernel, and we've done all the enhancements and enlightenments in the kernel to have it virtualize that OS instance. Where Hyper-V containers actually have their own kernel.
Right.
So each Hyper-V container, we take advantage of a special VM that we built and a special installation of Windows, even smaller than Nano Server, where the only purpose for those to be around is to run a container.
Right.
And so what this gets us is the same isolation we have with a VM, but the exact same management experience and the exact same container image experience as a Windows Server container.
Right.
So now we can run different versions of the kernel. So if you fast forward when we come out with the next version of the server, we'll still be able to run container images from the previous one on that with the right kernel and the exact same performance and exact same feature set as they previously had. Whereas Windows Server containers, because they're a shared kernel, you'll have to upgrade those container images, rebuild them to match the right kernel underlying it.
Right, but the management experience is unified across both, so,
yeah,
and the development experience.
Yeah, it's exactly the same. And in fact, we even have Hyper-V containers in client.
Okay.
So if you're a Windows 10 user, you can enable Hyper-V containers. And what that allows you to do is to build a server application using the server kernel. So even though it's the same kernel, we run the kernel differently if we're in server mode. We have different memory management policies and whatnot. Right. And different features, obviously.
Yeah. So
you can do all that development on your desktop machine as a Hyper-V container, and then ship it into production where it runs as a Windows Server container or as a Hyper-V container. So it's all very flexible.
And the choice at which whether running as a Windows Server or a Hyper-V container, just a deployment time decision you make.
Right. So it's just a flag.
Right.
The default on server is Windows Server containers. The default on Windows 10 is Hyper-V containers. That's the only ones that'll run there.
Right.
And then as an IT pro, you can actually switch that default. There's just a flag you can set to say, nope, the default on this server is going to be a Hyper-V container. You have to explicitly tell me to run a Windows Server container or keep the default the way it is, and then you just push a flag to Docker to say run that as a Hyper-V container.
So you've mentioned Docker a few times. I'm guessing it's pretty important.
Yeah.
If you've been in the container space, I guess, for a while, and you've not heard the term Docker, you're missing something. Explain to us about what Docker provides for Windows Server and Hyper-V containers.
Right. So Docker's effectively, they're a container management tool set. They've got a whole kind of management experience around it, but at the end of the day, you can really think of them as a container management experience. So there's a client that is a CLI-based client, or now we have PowerShell for Docker as well, that communicates over REST to an agent that's running on your server that actually does the hard work of calling the right system APIs to create a container, make sure that the image is all present, do all the networking, hookup, and whatnot, and actually start the container. And then Docker's also got a really great experience for managing container images. So there's a public Docker hub where you can push your container images to. So if you and I wanted to collaborate on a project, I could push a container image up to the hub. You'd be able to pull it down from the hub. We don't even have to be in the same country. Right. Just have to have internet.
It's like a shared repository that we can use publicly, but you can have private ones as well, right?
Right. So there's a private Docker hub registries as well as on-prem through the Docker trusted repository model. So I can have one that's in a VM, in my data center, locked away. No one gets access to it, but it's the same development experience either way.
Right. So when I'm deploying images, let's walk through a quick scenario. I'm deploying an image. I want to deploy a new Node.js application, for instance. That will be stored in the Docker Hub, whether it's something in the cloud or my private repository. I would choose to deploy that to a container host, a node in the Docker term. That would have the Docker agent installed there. So I'd have all of that communication. But what if I wanted to scale out? What if I wanted to start to deploy lots of containers across lots of container hosts? And I don't want to say physical servers, because a container host doesn't have to be a physical machine. It can be a VM, it could be a VM on-prem, it could be a physical, you name it. So how do I start to scale out containers?
So the easiest way to really start with that would be the Azure Container Service. So we've got a service in Azure where you can go and request a container service. And what that actually does is it uses our VM scale set technology to set up a whole bunch of container hosts, like be Linux or Windows, either way, and then uses a container orchestrator on top of that. So we have two different open source options. We have from Docker Swarm, and then Mesos and Marathon as the other one. And what those orchestrators do is they take in a set of container images and some metadata about those, and then scale them out across a set of hosts for you.
Right. And those hosts could be, in your case you mentioned, they could be Azure and Azure Container Service, but I could use those technologies for on-premises resources as well. Yeah,
absolutely. So one of the things that I think actually distinguishes our offering from some of the other ones out there is that we're just using open source components. And in fact, all of that, the JSON templates for how to deploy those are all open source as well.
Cool.
So you can easily reproduce that on-prem using the Azure stack, or just regular Windows Server, or in any other cloud you want to use it in. So if you're a very happy Amazon or Google customer, want to stand up Windows Server in there and then run containers, absolutely.
Cool, great. So in terms of recommendations for people to get started, because we've covered a whole host of stuff, we've talked about Docker, we talked about Windows and Hyper-V containers, loads of stuff. Where would you recommend people get started?
So as part of the containers project, we're using a new documentation system that's actually all backed in GitHub. Super easy to get there. Just go to aka.ms/containers. We've got some getting started guides on there. We've got some documentation on how to get started in Azure, how to get started on your laptop, how to get started in a VM. And ultimately, it just comes down to downloading the evaluation of Windows Server 2016, or if you're already a Windows Server 2016 customer, just enabling the containers role on that. Setting up the Docker engine, and away you go.
Nice, and the documentation is continually being updated, and the community can contribute as well.
Absolutely, yeah. So this is one of the best parts, is that if you think something could be a little clearer in the documentation, or you want to add a little script or something to help other people do it, it's just a pull request in GitHub. It's all in Markdown, super easy to add stuff to, and then we review it. We can discuss it in GitHub and push publish, and an hour later, actually usually less than that, usually about 5 minutes, it's live.
Nice. So
with your little icon saying, hey, I was a contributor.
Nice, you're 5 minutes of fame.
Yeah.
So where do people get started with Docker as well? Because obviously it's an important part of our container story.
Yeah. So we've got a whole bunch of references on our the same container site, aka.ms/containers. Or you can go to docker.com.
Right.
And so they've got some great references for that. Docker for Windows is a great developer experience. So that allows us to set up a container host for development. And the Docker machine is a great way to provision container hosts for production.
Nice. And another useful resource that you should be aware of is on Channel 9. It's the Containers channel that Taylor and I have both been involved in, and a number of other people have contributed that help you understand and visualize what's going on in some of these different scenarios around containers. So it can certainly accelerate your learning. So make sure you check out that. All that's left for me to do is to thank Taylor for his very tailored insight into containers. Hopefully you like that. And thank you for watching. Stick with us in the series as we continue our look at the 10 reasons why you'll love Windows Server 2016. Thanks for watching.